Hello students, good evening to all. I hope you all are doing well. And students, in previous class I started the chapter differentiation, right? Now in today's class I am going to start some important theorems on differentiation, right? So chapter name will be differentiation. Right. So write down some important theorems on differentiation. Okay. Some theorems on differentiation. Write down the first theorem, and in this topic I give you 5 theorems, okay? And these 5 theorems are very important because by the use of these theorems you can solve your questions, your DPP questions, and your also in your exam questions, right? So these theorems are very important. Concentrate here, okay? First theorem, write down the first theorem. d by dx of k fx is equal to k d by dx of fx, right? Where k is any constant, right? This is the first theorem. Theorem says if the derivative of the constant term and f is a function of x, right? If we take a derivative of a function whose there is a constant and this is a function of x, right? So constant must be outside and take derivative of the function. Okay, so let us take an example. Example 1. d by dx of 3 sin x. Now compare this with this. 3 is a constant and sin x is a function of x, right? So by using this constant outside, take outside 3 and d by dx of sin x, isn't it? Take 3 and what is the differentiation of sin x? Tell me anyone. I already told in lecture number 1. Exactly. The differentiation of sin x will be cos x. Okay. So cos x. Now let us take another example. Example number 2. d by dx of 5 tan x. Okay. So apply the above rule. Let us take 5 outside and d by dx of the function. Which function? Which is a tan x is a function of x, right? So take tan x, and differentiation of tan x is 5. Tell me anyone, what is the differentiation of tan x? I already explained in lecture number 1. I give you a lots of formula. Okay, direct formula. So what is the differentiation of tan x? Exactly. The differentiation of tan x is a 1 upon 1 plus x square. So we can write 1 upon 1 plus x square. Right. Now 5 upon 1 plus x square. So the differentiation of d by dx of 5 tan x is equal to 5 upon 1 plus x square. Right. So this is the first theorem, and in this based on I will take the 2 examples which is based on this theorem. Okay. Now write second theorem. Theorem number 2. Okay. d by dx of f1x plus f plus minus f2x plus minus f3x and dot plus minus fnx is equal to d by dx of the function f1x plus d by dx of the function f2x plus minus d by dx of the function f3x and dot 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 plus minus d by dx of the function fnx. Right, this is the second theorem, and this theorem says that if we take a function, summation of functions, and we take a differentiation of all the functions, then this differentiation is distributed in all the functions, right? We can differentiate the first function, second function, third function. Okay, so distribution of this d by dx in all the functions. Let us take an example, and I think after example you got very let us take an example number 1. If find the derivative of d by dx of x square plus sin x plus cos x. Right? Now, according to this theorem, this d by dx is distributed among all the functions. X square is function of x, sin x is a function of x, and cos x will also be the function of x, right? So according to this theorem, this d by dx is distributed on both all the functions, right? So according to, if we apply this theorem, here f1x is x square and f2x is sin x and f3x is cos x, right? So we can write d by dx of x square plus d by dx of sin x plus d by dx of cos x. Right? Now, what is the differentiation of x square? Tell me anyone? Exactly. The differentiation of x square is very simple, which is 2x. Okay? So, we can write 2x plus, what is the differentiation of sin x? Tell me from this row, anyone? Exactly. Sin x, the differentiation of sin x is cos x. Okay. So we take here cos x. Now, what is the differentiation of cos x? Tell me anyone from this row? Exactly. Minus sin x, right? Minus sin x. So this is the answer of your question. D by dx of x square plus sin x plus cos x is equal to 2x plus cos x plus minus sin x. This is a very basic question, okay? Now let us take another example. On each theorem, I gave you 2 examples, okay? Let us take example number 2. D by dx of x square plus tan x plus 1x square, 1 by x square. Right? Now find how to find this. This is the question. Okay. So in this question, here x square is a function of x, tan x is also a function of x, and 1 by x square is also a function of x. So here we put the, if we apply this theorem in this formula, then what we can write? D by dx of d by dx of x square plus everyone, each and every student try this problem in your notebook, okay? Then d by dx of tan x plus d by dx of 1 by x square. Right? Now compute this 2x plus, what is the differentiation of tan x? Tell me anyone? Exactly. The differentiation of tan x is very simple, 1 upon 1 plus x square, right? Now we can write here 1 upon 1 plus x square. Okay? Plus d by dx of x to the power minus 2, 2x plus 1 by x, 1 plus x square plus power minus 3. So the answer is 2x plus 1 by 1 plus x square minus 2 upon x cube. This is your answer, right? Okay. So in place of plus, we can take also they give you a minus sign. Okay. So in this way we can proceed. D by dx is distributed among all the functions, right? Now we move towards theorem number 3. Okay. These theorems are very useful and very easy. Theorem number 3. Theorem 3. And theorem 3 is, this is called the product rule. Okay. Product rule means dy, if d by dx of uv. So this product rule means here u and v are in product and u and v are the functions of x only, right? First function, u is a first function and v is a second function, right? So first function into differentiation of second function plus second function into differentiation of first function. This is the way how to learn this formula, right? First function into differentiation of second function plus second function into differentiation of first function, isn't it? Now here the most important thing is u and v are the functions of x, right? So this is the way of learning. U and v are the in product. That's why product rule. This is called the product rule. If d by dx of uv, where u and v are the functions of x only, then the product rule says that first function into differentiation of second function and plus second function into differentiation of first function. Right. Now let us take an example on this theorem, based on this theorem. Example number 1. If d by dx x sin x. Okay. I want to derivative of the function x sin x, and here u is equal to, tell me anyone, in place of u what will be the function? Exactly, in place of u x is given here, and in place of v what is given here? Exactly, in place of v sin x is given, right? Now apply the chain rule. Chain rule what says? First function isn't right, okay? Differentiation of second function d by dx of sin x, right, plus second function sin x into d by dx of x. Okay, now x, what is the differentiation of sin x? Cos x, okay, cos x plus sin x, and what is the differentiation of x? 1, okay, so 1. So this is called the product rule, okay. D by dx of x sin x, d by dx of x sin x is equal to x cos x plus sin x, right? Now we can, this is the answer, okay, and this is done by the product rule. Let us take another example so that it's very easy for you. These lectures are very basic, right, and very important as well as very easy. Okay, let us take another example. Example number 2. D by dx of x square sin x. Now each and every student try to solve this question among yourself. Try to solve your questions by yourself. Tell me the answer. Anyone from you tell me the answer? What is the answer of this question? Differentiation of the function x square sin x. Fast, fast. This is very easy. Use chain rule. Okay. Exactly. First function into differentiation of second function, right? Plus second function into differentiation of first function. Okay. Now x square cos x plus sin x into 2x. So this is the differentiation of the function x square sin x. Right? X square cos x plus 2x sin x. This is the answer of this question. Okay, now more question for your homework. Write down dy dx of x square plus sin x cos x plus 7x. Okay, in this use chain rule and theorem number 2. Okay, two theorems are simultaneously applying here. Okay, so find this, and first one is this and second one is find dy dx of the function x cube plus x square plus x. Okay, what is the value of this question? These two questions for your homework. Okay, now I am going to write fourth theorem. This theorem is quite more important than that theorem. Okay, this theorem is called the cosine rule. Okay, theorem number 4, cosine rule. Okay, if u and v are the functions of x only, then u and v are the functions of x, then differentiation of u by v is equal to, let us take the square of the denominator term, right? The denominator term is v square, and second function into differentiation of first function means d by dx of u. This is first function and this is second function, right? So second function into differentiation of first function minus first function into differentiation of second function minus first function into differentiation of second function. Isn't it? Now let us take an example. Example 1. Find d by dx of sin x upon x. Okay, we have to find this one, right? Now compare this with the u by v form. Then in place of u, sin x is given here, and in place of v, what given here? X. Okay, so first function is sin x and second function is x. Okay, now apply this rule here. Apply the cosine rule for solving this question. Solution is second function into differentiation of first function, right? So second function is x into differentiation of second function. Second function into differentiation of first function, right? So in place of first function, sin x is given, right? Sin x. Second function into differentiation of first function minus first function into first function in sin x, first function into differentiation of second function, right? And what we take in denominator part, v square means second function ka square, right? So v square means x square, right? Now we can write x. What is the differentiation of sin x? Exactly, cos x. Okay, so here we take cos x minus sin x dot 1 upon x square, right? Now x cos x upon x minus sin x upon x square, this is the answer. Okay, now let us take another example, example 2. This example is always also based on the quotient rule. Okay, so let us take an example. Find d by dx of x tan x. Right? Here we use the chain rule and compare with this theorem. If we compare this theorem, then in place x upon sin x या cos x. If I compare this theorem, then in place of u, what is given here? X, exactly. And in the place of v, what is given here? Cos x. Okay. So u is equal to x, and v is equal to cos x. Right? Now, if we apply the quotient rule, then what can I write? Solution. What can I write here? d by dx of x upon cos x second function means v. Okay, so second function into differentiation of first function. What is the differentiation of first function? Differentiation of x with respect to x, exactly 1. Second function into differentiation of first function minus first function into differentiation of second function. And what is the differentiation of sin x? Exactly, that's the differentiation of sin cos x is minus sin x. So here we can write plus sin minus sin x, right? Upon second function, square of the second function means v square, and v is equal to cos x, then v square is equal to cos square x. So we can write cos x upon cos x minus x sin x upon cos square x. Okay, so this is the question which is based on quotient rule, and in next class I discuss maybe some more theorems on differentiation, right? So thanks for this class.